dynamic sites in the whole world and was closed on July the 10th after the park authorities found cracks in the rocks. Although the supervolcano has not seen an active eruption in 664,000 years, scientists are monitoring it very closely and consistently. A supervolcano is thousands of times more powerful than a normal volcano and could result in changes across the globe. Scientists even believe that an eruption would eject 240 cubic miles of material, and a pyroclastic flow would cause volcanic ash to be ejected miles into the air and scattered across the whole of the United States. The sheer volume of ash would be devastating and could kill people, plants, animals, and even crush buildings and flatten cities. Yellowstone is the site of the largest and most diverse collection of natural thermal features and is one of 5 USGS volcano observatories that monitor volcanoes for science and public safety, as well as being situated on the Snake River Plain Yellowstone hotspot, an area of tectonic activity. The region also has an abundance of hot springs and deep mud pools that gather liquid and gas beneath the surface. Because of this, small quakes are frequent occurrence in Yellowstone, which is typically hit by 1,000 to 3,000 quakes a year. Yellowstone volcano is subject to much speculation over whether there will be a major eruption in the future, but now national park authorities have a more pressing issue to worry about, as experts warn toxic gas venting from the supervolcano itself. Yellowstone National Park is home to thousands of hot springs and geysers spewing clouds of mostly harmless rotten smelling gases. But in the deeper parts of Yellowstone wilderness, where tourists are told not to stray, toxic fumes of lethal gases are powerful enough to kill. USGS scientists studying the Yellowstone volcano have warned of the ever-present danger in their latest issue of the weekly Yellowstone Caldera Chronicles. USGS experts have announced that dozens of Yellowstone animals have dropped dead over the years as a result of inhaling toxic fumes. The two killers are poisonous levels of carbon dioxide and hydrogen sulfide, which are concentrating around ground levels. Most of the gases emitted by Yellowstone network of hydrothermal pipes are harmful to gases, but hidden in these emissions could be concentrations of toxic gases which have proven to be lethal to animals. CO2 is particularly dangerous because it is odorless and colourless gas. H2S, hydrogen sulfide, on the other hand, is easier to spot thanks to its distinctive smell of rotten eggs, but the gas is also colourless and flammable. Both gases typically pool around ground level because they are heavier than air. This can be absolutely lethal to animals grazing in the park fields with their noses close to the ground. What's actually underneath Yellowstone though? Yellowstone, like Hawaii Islands, is believed to lie on top of the planet's few dozen hotspots where light hot molten rock rises towards the surface. Over the past 17 million years or so, successive eruptions have flooded lava over the wide stretches of Washington, Oregon, California, Nevada, and Idaho, forming a string of comparatively flat calderas linked like beads as the North American plate moves across the stationary hotspot. Currently, volcanic activity is exhibited only via numerous geothermal vents scattered throughout the region, including the famous Old Faithful geyser, but within the past 2 million years, it has undergone 3 extremely large explosive eruptions, up to 2,500 times the size of the 1980s Mount Helens eruption. Scientists was wrong about what powers the famous Yellowstone volcano in a discovery which could change the way experts look at the powerful caldera. It had been long believed that the source of the Yellowstone eruption came from a heat deep in the Earth's core, which rose to the top to power explosions. However, according to new research, the devastating eruptions were actually caused by gigantic oceanic plate which broke into pieces tens of millions of years ago, unsettling the mantle beneath Yellowstone, leading to some of the most violent lava explosions in the history of the world. Experts created X-ray images of the layers beneath the Wyoming-based supervolcano and found a shattered oceanic plate at the depth of about 250-400 miles right beneath Yellowstone. Instead, the underground images captured suggest that Yellowstone volcanoes were produced by a gigantic ancient oceanic plate that drove under the western United States about 30 million years ago. This ancient oceanic plate broke into pieces, resulting in perturbations of unusual rocks in a mantle, which led to volcanic eruptions in the past 16 million years. This evidence was in direct contradiction to the plume model. Scientists found that the oceanic Farallon plate, which used to sit where the Pacific Ocean is now, had somewhere forced itself beneath the western parts of the United States. days. As the Farallon plate crumbled, it sank even further into the ground and pushing hot material from the Earth's core upwards to form what is now Yellowstone. The process started at...
Oh, there it is. You take cards? Per person?
$35?
I thought it was like, oh, I have to like walk in to get the 20.
Yeah. There you are.
Thank you.
Pass is good for 7 days. Show us the receipt if you're in.
Thank you. That's the old pitfall.
the Oregon-Idaho border about 16 million years ago and propagated northwestward, forming a line of volcanoes that are progressively younger as they stretch northwest to the present-day Wyoming. If the North American plate was moving slowly over a position-fixed plume at Yellowstone, it would displace older volcanoes towards the Oregon-Idaho border and form a line of volcanoes, but such a deep plume has not yet been found. It has always been a problem there, and scientists have tried to come up with different ways to explain the cause of Yellowstone volcanoes, but it has been very unsuccessful. The next step will be to increase the resolution of the X-ray-like images of the underground rock. More detailed images of the unusual rock in the deep earth will allow us to use computer simulation to recreate the fragmentation of the gigantic oceanic plate and test different scenarios of how rock mountain and magma feeding system work for Yellowstone volcanoes. Yellowstone will soon erupt. Understanding more about the caldera may help us understand how far away this event might be, and when it does, the planet Earth will need to be prepared. When